So this question is a very interesting question. So you have like this nice calculator that only has two keys, so it's a pretty like broken calculator. And you can either add one or multiply by two. So when you press one of the keys, the calculator automatically displays the result. So for instance, if the calculator originally displayed 9, and then you press +1, then it would display 10. And if you press ×2, it would display 20. So starting with the divisibility display 1, we want to know what is the fewest number of keystrokes you would need to reach 200. So this question is like it's kind of an interesting question, right? So the idea for this question is like one way to do it is kind of like to work backwards, right? So you want to get from 1 and you want to get to 200. So you want to get there as fast as possible. So the idea is like you can kind of like work backwards, right? So we can kind of start from 200 and try to go down to 1 instead. And we can pretend, we can kind of pretend that like instead of ×1, or not ×1, +1, instead of +1 and ×2, we can kind of think of the reverse operations. We can instead think of -1 and divide by 2. So for 200, clearly, like intuitively, if you just think about it, it would make sense that we want to divide by 2 as much as possible, right? Because like dividing by 2 is a lot faster than subtracting 1. Well, technically, you can also do it the other way, +1 × 2, but I guess we can do it backwards as well, right? So from 200, it would intuitively make sense to go to 100. Like we could go to 199, but like that's not very good progress. We don't really want to do that, right? So like we would just go to 100. Then from 100, we would go to 50, divide by 2. From 50, we can go to 25. From 25, we can't divide by 2 anymore, but we can still subtract 1, right? So 25, we subtract 1, you get 24. Now we can divide by 2 again. So we get 12. And then 12, we divide by 2, you get 6. 6, you divide by 2, you get 3. 3, you cannot divide by 2, but you can subtract 1. So that becomes 2. And then 2, you can subtract 1, you get 1. So in total, this takes 1, 2, 3, 4, 5, 6, 7, 8. Or wait, what was the question asking? What was the fewest number of keystrokes you would need? Wait, to reach 200, right? So 1, 2, 3, 4, 5, 6, 7. Oh yeah, 8, 9. Right, this one too. So like in total, this would require, let me like do it in a different color, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're essentially counting how many arrows there are because each arrow represents like a transition. In this case, we like worked backwards. Honestly, you didn't actually need to work backwards, right? You could have like started from 1 and then try to go to 200, like intuitively. But the reason why that might be a little harder is because like it might not like it might be harder to like realize when you want to start like adding 1, right? Because if you started from 1, then if you were to try to follow this kind of like greedy strategy, right? So like in this case, we kind of did like a strategy that was like we keep dividing by 2 until we can no longer divide by 2. Then we subtracted 1, then we keep dividing by 2 and we subtracted 1. So like this is actually like you might sometimes hear this referred to as like a greedy algorithm. This is often, it's more like a computer science thing, but like in this case we wanted to keep dividing by 2 until we could no longer do so. So a lot of times like this isn't like a completely rigorous like solution, right? Like but like it gives us like it's kind of like intuitive. Like it makes sense that we would want to divide by 2 as much as possible to get the numbers as small as possible. Like subtracting 1 is not like as optimal compared to dividing by 2. And we just went through this process. I mean, in total, we counted like 9 transitions. So like the answer would just be B, which is 9. And yeah, we would be done.